Hello everyone. This lesson we're going to show you how to calculate ground fault detection system. We mentioned before, for ungrounded delta system, we need some kind of ground fault detection system. Because if we have one line grounded, nothing going to happen. But if we have a second line grounded, then we're going to have a big trouble, have a line-to-line short circuit. So to preventing that, we usually have a ground fault detection system in an ungrounded delta system. Here's a basic ground fault detection system. We have an ungrounded three-phase delta supply system at 480 volts. Then we connect three lamps on each of the line. We have a lamp connect one terminal, another terminal of the lamp. We connect them to a common point, then we ground the common point. So in this case, we can see if something happens, what's going to happen to this circuit. The green drawing here is when we have accidentally ground one of the lines, then we will have this green line. So we look at normal condition first. Under normal condition, this is a three-phase 480 volts delta system. So the line voltage is going to equal to 480 volts. But because our three lamps, they have a common connection, connect to the ground, so all three lamps is connecting Y. We find the voltage drop across the line, across the lamp, is we try to find the phase voltage in the Y system for those lamps. So the phase voltage is going to be equal to the line voltage in the system divided by root 3, 480 volts divided by root 3, give us 277 volts. So under normal condition, each lamp is going to say 277 volts. Now, we pretend there's a line C have accidentally grounded. Because it's accidentally ground, causing line C have the same potential as our grounding point. When they have the same potential, they look like there's a wire connected between them. So, under ground fault condition, our supply is still 480 volts, but the line C is connected to the ground. So now, the ground also have the same potential as line C now, because they are connected by the grounding point. Lamp A now is connected between line A and the line C, because ground have the same potential as line C. So lamp A gonna see the voltage between line A and the line C. So because that voltage across lamp A gonna equal to the line voltage, gonna equal to 480 volts. Same thing happens for line B. The lamp B is also connected between line B and the line C. So lamp B gonna say 480 volts. But the lamp C now is connected between the ground and the ground, or line C and the line C. So there is no potential difference across lamp C. Lamp C gonna say 0 volts. For that we can say when the lamp C is 0 volts, the lamp C is gonna become dark. It's not gonna come on anymore. Before, each lamp is saying 277 volts. Now, lamp A and the lamp B are going to say 480 volts. So, these two lamps will become brighter, and the one lamp will go dark. Under normal condition, each lamp say 277 volts, so all three lamps are going to somehow in a dimmer way. Here's a calculation for a ground fault system in a three-phase ungrounded delta system. Next one, we're going to cover the voltage calculation in three-phase 4-wire delta system. In some kind of industrial place, they want to use 120 volts for the receptacle for certain kind of lighting. So even they have a three-phase 3-wire delta ungrounded system, they will ground the center point of between phase line B and the line C, creating a center point to ground them to put a neutral conductor in there to become single phase 3-wire supply. So for our system, it's still 240 volts, 3-phase delta system. The line voltage equal to the phase voltage equal to 240 volts. When ground the center point between B and the C, the voltage between B and the neutral and the C to the neutral will be half of the voltage between B and the C. So here's a diagram to indicate if we center tap between B and the C, the voltage from B to the neutral and from C to the neutral will be half of our line voltage, 240 volts divided by 2, give us 120 volts. The most important, we try to find out what's going to be the voltage between A to the neutral point. By the code requirement, phase A have to be the high lag. So why they call the high lag? Because the voltage from phase A to neutral will be higher. If you still remember our famous triangle 1, 2, rule 3, or you look at it here, when we have 3 equal sides, it's an equilateral triangle. If we divide from the center from A to neutral, this will be 60 degrees, this will be 30 degrees. Now we can use trigonometry to find out the voltage between A and the neutral. We can use AC voltage square subtract C to neutral voltage square, take the square root, will give us 208 volts. If we apply 1, 2, rule 3, we can also use 120 times rule 3, give us 208 volts. So here is the voltage calculation for 3-phase 4-wire grounded delta system. If you have a question, you can connect us online or send us an email.